Um, Hello, um, and good afternoon. Yeah, I'm doing this recording. It's around midday, and yeah, let's go through machine learning today. So today's topic is about machine learning, and I'm from group. I don't even know which number this is, but I'm from group two. Yeah, we put group two. I'm from group two, and I have two other colleagues who probably are going to be discussing about the same thing. So if we are to go on through the content of the presentations, we're going to go through the introduction, get to know what supervised learning is, and supervised reinforcement learning, the comparative analysis, and all the other things that are going to come. So I can say, so in the introduction, we can see that there are very many higher education institutions, and they kind of have students. You might even not go as far as high school, but you could go to like primary schools and all that. You know how it is a very competitive world. um, you see, like in Uganda, you feel like you get into a situation where um, schools are competing for like first grades. They want to be able to obtain first grades of maybe a certain quality. They don't want to get second grades and things like that. So there arises a need where um, where schools need to pick out and identify students who might be struggling in their classes, struggling in maybe different subjects or in their classes, because when those students fail, the overall performance of the school goes down. So there is we could try this in like machine learning, which is which is a science of artificial intelligence. Now, to define machine learning for short, it is a subfield of artificial intelligence that focuses on developing algorithms and statistical models that enable computers to learn from and make predictions or decisions based on data without being explicitly programmed for each task. Now, so we have reached a point in life where we actually don't want to program, but we want the computers to be able to learn specific patterns within data, so that they can be able to identify those patterns or tasks, or accomplish a task all by themselves without actually having a man behind the screen. So how can we do this? How can we use this machine learning in like our idea is to help schools that want to predict their students who might fail. That is, who might fail, so that they're identified early and they're what they can easily be helped. So we can start. Machine learning, we can classify it into three types. That is supervised learning and unsupervised learning and reinforcement learning. Now, let's start with something that is easy to implement. So let's picture it this way. In supervised learning, the machine learning ML is machine learning. So the machine learning algorithm is trained on labeled data. This is like you have data that is in sets, that is in pairs of, this is the input and this is the output that data gives. So what happens? How can we use this in like our project? So schools keep all this data. They keep information about attendance, they keep information about performance in tests, and the overall result of a student. I can say a candidate because that is where the market is. So we know the input data, which can be the students' attendance, the students' test results, the students' behaviors of classes and things like that. And we know the output, which is they passed or failed. I don't know if, yeah, I hope you do understand that they either passed or failed, because we want to predict from that data. Like, we want to use that data to train the model, and then when we give it real data, it can be able to get from its inputs and predict if a certain student will fail or pass, depending on the criteria that they meet on this side. So I guess that is how we can use machine learning to supervised learning, sorry, to tackle this problem in that way, whereby I can say um, we have the data available because the schools do record this data. So even if it's not documented, the teachers will always know about their students. So it's like the data is readily available. You just have to apply supervised learning onto your model, and you'll be able to pick something. Now let's go to unsupervised learning. Um, okay, it's not like, please don't picture it in a way that a computer is going to do exams and it's not going to be supervised or to cheat. No. This way we train models on unlabeled data. Now in supervised learning we have labeled data. We know the inputs and the outputs, but this side we have a data set where the individual data points or instances don't have corresponding labels or annotations. You get? In other words, the data is not categorized. The goal is to find patterns or structures in the data without explicit guidance. Now let us put it back to our project. Let us assume we want to use another school's data. And the data may not be labeled by the specific student who passed or failed, but we have the data on attendance and other factors. So what do? We are going to group it and cluster it. Now here we do what we call cluster. Will be like we are going to cluster uh, um, students who might have failed. Sorry, we are going to base on like the data points. What should I say? The criteria. So we're going to group students who maybe miss attendances, students who failed or passed tests, or things like that. And then we form different clusters, and then we map those clusters to our outputs, something like that. So if you're not going to use supervised learning, you could try using unsupervised learning. You can use any other schools that I know, like I'm sure there are schools that are kind of nosy. They want to know what their maybe competitors are doing. So if you like get your hands on that data, I don't know how you do it, but I guess you could try that too. So that is unsupervised learning. Then we go to reinforcement learning. Now here, I'm even tired. I feel like we can stop here because we already have a solution. Like just use supervised learning or unsupervised learning. But anyway, I'll still do it. I am your person. Yeah, I have to pass on the knowledge. So in reinforced learning, um, it sounds like it's actually a first thing, but it is not. In this kind of learning, the agent is like another student, but it is learning about the behavior of the students and their resultant outcomes. Now let's say your school is unique, like in a country like Uganda everything is possible. So you have students, you kind of have students. Oh my god. Yeah, so where had we stopped? Yeah, about reinforcement learning. Now here the agent does a trial error approach. Remember, we defined the agent as the computer that learns, that is actually going to do the learning, the machine learning. So it does a trial and error approach where it adjusts its actions depending on the environment. Now let me give an example. Let me say a model gets data about students who maybe have missed class 5 times, and it's predicted that when a student misses class more than 5 times, they're bound to fail. Then so it predicts that student to have going to fail. But then when you reevaluate the work, you find out that the student actually passed, so the computer erred. So it has to go back and reevaluate its inputs so that it can get a better approach, it can get a better answer in another try, something like that. So that is reinforced learning. The agent uses a trial error method. So congratulations schools, you have another student who is a machine learning agent. So if we could literally use this type of machine learning also. So going deeper, yeah, still a lot to cover. We can go back to supervised learning. How does it do it? Supervised learning uses two things. There is classification and there is regression. In classification, okay, to say it simple, classification marries discrete values, and then regression marries continuous values. And then, yeah, happily ever after they lived. But anyway, back to business. When you go into the details, in classification, the output labels are discrete classes. Now, what I mean by discrete is that there is no man in the middle. The student is either predicted to have failed or to have passed. So that is classification. So when you're using supervised learning, you apply classification if you just want to group your data, or you want to have two outcomes in two discrete values, that is passed or failed. Now, if we proceed and go to regression, regression is continuous. It is different from what? From classification. Maybe you're interested in finding out the degree at which someone passed, or the degree at what someone failed. So you're going to have a continuous value, maybe like let me put it for the case of like PLE. So from like 4 to 6 aggregates, then there's 7 to 9, then there is like 9 to 12, then you enter second grade and something like that. So that is regression. Those are the classes that you are having. So in simple terms, if you have continuous grouping students of this category, it works when there is no discrete way of grouping things. That is when you use regression. Now when we go to unsupervised learning uses what we call clustering. Here, the algorithm groups similar data points together into clusters based on their properties. And it uses K, meaning clustering, density-based clustering, hierarchical clustering, such things. But then let us keep it to our project. So we could group students, like maybe those ones who miss classes, maybe those ones who didn't pray towards exams, or those ones who don't consult. So it could be anyway, and you form clusters of that kind. Then the clusters you obtain, you can you need to interpret and understand their data so that you can be able to gain from them. So you use visualization techniques such as scatter plots, heat maps, that can be used to visualize these clusters, explore the relationships between the clusters, and then you gain insight. So if the clustering is actually done well, you can get a well working machine model that can prove to be useful. So unsupervised learning is practically used in experimental data analysis, where the goal is to gain insights into the underlying structure of the data set. Now, for reinforced learning, like we said, we have an agent and we have an environment. The agent learns from the environment. So for our case, it could be a student missed class. I guess I explained this before. I just have to explain it again maybe. Or the agent could still, the agent could so the agent, remember, gets an input and predicts an output. That is how it learns. When it fails, it reevaluates its inputs and tries another output. So literally that is reinforced learning. I don't want to repeat it. It can be categorized into several types. That is model-free reinforced learning. RL is reinforced learning, model-based reinforced learning, and policy gradient methods. So in the free model, the algorithms learn directly with interaction. There is direct interaction with the algorithm and the environment, without explicitly modeling the environment's dynamics. So it can be Q-learning, SARSA, and deep Q networks and things like that. Then for model-based reinforcement learning, the algorithms build an explicit model of the environment's dynamics and use it to plan future actions. I don't know how I can illustrate this, but yeah, model-based methods often involve a combination of learning the model and using it for planning or decision making. Yeah, I hope it does make sense. Then for the other one, policy gradient methods, these algorithms directly learn with a policy function by optimizing the parameters of a policy neutral network to maximize expected rewards. And that is it. Then the challenges. Of course, there are challenges in everything. How could we miss out this? So you could find there are challenges of data quality, being able to get complete and accurate data, because computers still remain computers even if they're doing machine learning. So if you feed them with garbage, you get garbage. That is garbage in, garbage out. So there is need to actually get quality data and computational resources. This machine learning involves a lot of resources. As far as RAM is concerned, the data that is concerned, CPU power to actually process this training data for the computer to be able to understand. So that is one challenge. Then interpretability and explainability of the data. Understanding how machine learning models arrive at their prediction is crucial for building trust and identifying potential biases. So there is need for that. Then privacy concerns. Collecting and storing student data raises privacy concerns. The parents, who are the stakeholders of the school, might not be happy with it. Ugandans here are also like very reserved people, so it's not good to just give away their information. Then bias and fairness. Machine learning models can perpetuate existing biases present in the training data. This can lead to unfair predictions, and I can see where that is going. So if the data is biased, you're going to get a biased model and you are not going to be able to achieve what you want. Then algorithmic justice. We have human judgment and oversight, student well-being. Oh no, sorry, I'm out of that. So these are ethical considerations. Bias and fairness. You have to make sure that your data is not biased and it is fair. So even if you attempt to do work and you get wrong work, you actually have to take it the way it is. You don't have to manipulate it in order to get what you want. And then human judgment and oversight, the students' well-being. Addressing these challenges and adhering to ethical principles requires a multi-pronged approach. Data collection and pre-processing, ensuring data quality, minimizing bias, and obtaining informed consent from students and parents is crucial, because the parents might not be okay with it. Then model selection and interpretation. Choosing interpretable models and providing explanations for their predictions can help build trust. So you have to kind of like explain to the people who are going to be using your work. You don't just do things and then you leave them there. People will not be able to understand you. Then there is need to have transparency and accountability. So clearly communicating how algorithms are used and who is responsible for their implementation is essential. Then there is need for continuous monitoring and evaluation. We can't fully trust the machine, so you need to kind of like monitor it and evaluate its work using maybe that confusion matrix to find out that everything is perfect. Then yeah, I guess we can say that. So key points to take away from this presentation as I come to an end. Higher education institutions want to predict which of their students might need extra support in their performance. Then we learned about machine learning techniques. Then we learned about, so that brought in supervised learning. You train using labeled data. Unsupervised learning, which uses unlabeled data, but it identifies patterns in the unlabeled data and groups it into clusters. Then in reinforcement learning, we have an agent that interacts with an environment, uses a trial and error kind of approach in order to get what it wants. Then so you have to choose the appropriate machine learning type based on your data and your goals. Yeah, so what you have is what leads you to the other thing. Supervised learning uses classification and regression. Remember, we said classification goes for discrete and regression goes for continuous. Then unsupervised learning, clusters come back. That is clusters. You're going to group data depending on how it is related. Reinforced learning, define the agent, get the environment, reward the system. Data quality and biases are crucial. Please, they are so crucial. When your data is biased, you're not going to get what you want. Interpretability and ethical considerations are important to avoid discrimination, and continuous monitoring and evaluation are necessary. So thank you so much for listening to me. I guess I can come to the end of this, and that was it.